Alright, James, we're going to start trig this week. So we're going to do a very basic, just right triangle trigonometry, and it's just a touch of trigonometry. The rest of it you will get when you do trigonometry in pre-calculus. So this is just a very, very basic introduction that is necessary for geometry moving forward. So repeat after me. So-ka-toa, so-ka-toa, so-ka-toa. It's a very funny saying that will really help you with this unit, and I'll explain in a minute, but get that in your head, so-ka-toa. So to start with, let's talk about ratios. So you know ratios, in the past you've seen like 2 to 3, or we can also write them as fractions, so like 2 to 3. And what a ratio basically is it's a comparison of two quantities. And specifically for geometry, when we talk about a trigonometric ratio, we're talking about the comparison of triangle quantities. And for you right now, they're only going to be right triangles. But in the future, they'll be more than just right triangles. All right, so abbreviations to remember has to do with so-ka-toa. So the first, what we call trigonometric ratio, there are 3 of these in geometry. So there's 3 of them. The first one is called sine, but we abbreviate it without the E for some reason. So it's abbreviated as sine like this, and you read it sine. And what that is, if you look at the so up here, when we're talking about triangles and angles, I'm going to draw, let's see, I'll draw one over here. Let's draw a right triangle. All right, so if I'm talking about this angle right here, usually that angle is represented with some sort of variable, so I'll call it x. So if we're talking about angle x, and this is a right triangle, then there are 3 sides in relation to x. There is the one straight across from it, and this is the opposite side of x, because it's straight across from x, so it's opposite. Then there's the longest side of a right triangle, which you already know is called the hypotenuse. Hypotenuse. And finally, there's this side, and it's not the hypotenuse, but it's not opposite. We say that it's adjacent to this angle. So it's like next to this angle, but it's not the hypotenuse. The hypotenuse is also next to, but it's not as long as the hypotenuse. Adjacent. That says adjacent. I couldn't fit it in very well. So trigonometric ratios are going to be comparing the lengths of these 3 sides. Depending on the look of your triangle, these will have different ratios. For example, this side might be 2 to 3 in this triangle, but if we were to draw a different triangle, maybe this triangle, that looks somewhat different. Maybe this is 1 and this is 2. So the ratio of the opposite angle, opposite sides to hypotenuse is different in these 2 triangles. This one, the ratio would be 1 to 2, and in this one, the ratio would be 2 to 3. So when we're talking about the 3 trigonometric ratios, we're talking about comparing sides. All right, so going back to sine, up here we said so, and that's to help you remember that sine is opposite over hypotenuse, or So, for S for sine, O for opposite, H for hypotenuse. So in other words, in this triangle, our sine would be 2/3, or 2 for opposite, over 3. All right, so the next comparison we can make is we can compare the adjacent side over the hypotenuse. Instead of the opposite, we're doing adjacent over hypotenuse to see how those two side lengths relate to each other. And that is called cosine. And we represent it with the letters COS. So it's just a shortcut. And if you remember up here, I made you say, so ca, and the A and H stand for adjacent over hypotenuse. So let's say this triangle right here, this was a side length of 2.5. Then the ratio would be, for cosine, 2.5 over 3. We'll do more of these in a minute in case you don't get it. All right, and the last but not least, we have something that starts with a T, because I made you do TOA, tangent. And tangent is O over A up here, so you guessed it, it's opposite over adjacent. Oh, and this one's represented with just tan. So hopefully I can fit this, opposite over adjacent. Sorry, that was a little squeezed in, but opposite over adjacent. All right, so every angle down here, saying trig ratios compare two sides of a right triangle. So we saw that in each one, it's comparing just two of the sides, not all three. Every angle has a specific trig ratio. So what that means is that if I was to redraw this same triangle, but we look at a different angle, so let me redraw that. Let's say 2, 3, 2.5. If we look at this angle instead of this one, their ratios will be different. So up here, we said the sine was the opposite across from this angle, 2 over 3. But when we look at this triangle, the opposite side is now different. This would be considered opposite. This stays as hypotenuse because it's in a right triangle. It's the longest side. So the sine for this triangle, sine of x in this triangle, would be 2.5 over 3, opposite over adjacent. So when you switch angles that you're looking at, the side labels switch. When we looked at this one, it was adjacent for this bottom side, but when we look at the other angle, then it becomes opposite because it's across from it. All right, so what we're going to do here is practice that with a triangle KLJ. So we're going to find all three for two different angles in this triangle. So we're going to start with angle J right here. So if we think about angle J for a second, look across from angle J. This side would be opposite. The hypotenuse is always across from the 90-degree angle. That has to be the longest side. That's hypotenuse. That leaves this one as adjacent because it's kind of like it's next to this angle, but it's not the hypotenuse. All right, so let's start off by finding sine. So OH will be opposite J. Oh, that's 24. 24 over so that's hypotenuse, or 40. And then you would want to reduce that, which, let's see, that's 4, 10, 6 over 10, which is 3 over 5. Yeah. All right, so sine of J would be 3 over 5. Okay, well, Oh no, my computer just went off. Okay. All right, so let's do cosine. So if you remember from up here, cosine is adjacent over hypotenuse. We just said that the adjacent side to j is the bottom side here. So cosine of j equals 32 over hypotenuse. So we're just simply plugging in for these ratios. So this is 40 for hypotenuse. And last but not least, and then you would want to reduce that, which is gonna 4/5. Okay. Last but not least, tangent of j. So if we remember from up here, we said that tangent was comparing the opposite side of an angle to the adjacent side of an angle. In the j's case, opposite is compared to adjacent, so tangent of j would be 24 over 32, or 3/4 to do my reducing in my head. All right, so you can see that depending on how long the side is, the fraction is different in each of these. Yeah, so the cosine here, because it's close to 1, it tells us that the adjacent is close in value to the hypotenuse. So 4 is pretty close to 5, whereas 3 is less close to 5. So these are further apart in value. All right, let's do k. So now we have to switch side labels because we're looking at this angle instead. So if you look at k, then this base now becomes not adjacent, but opposite. This is opposite for k. And then this stays as the hypotenuse because it's the longest side. This side becomes the adjacent side because it's not the hypotenuse, but it's next to this angle. All right, that's the hard part, identifying what the side labels are. Now we're just going to plug in. So sine of k is going to be opposite over hypotenuse, or 32 over 40, which simplifies to 4/5. If we do cosine of k, that is adjacent over hypotenuse. So the answer to that one would be 24 over 40, or 3/5. And last but not least, we have tangent of k, and that's comparing opposite over adjacent, so 32 over 24. That turns out to be 4/3. Okay, so if you look, most of them are the same for these, but just switch. So 3/5 was cosine for k, but it was sine for j. So they switch around. Tangent is kind of special. It is the only one that can be over 1 in value. All right, so when we talk about trig, you can actually get a value for any degree. And the way you do that is you have to use a graphing calculator. Let me move this up a little bit. Sorry. But to prepare your graphing calculator, we're just going to show you how to plug these in, and then I'll show you what it means. Okay, so when you have your calculator, you're going to turn it on. And an important thing with calculators is that there's different ways to measure angles. And in the United States, we use a specific thing called degrees. But later in trig, you'll discover there's other ways to measure, like radians, and you don't have to worry about that right now. But in other words, you need to make sure your calculator is on the correct mode. So just hit mode right up here, and then it's going to come up with all these things. The third line is what you're looking at. You want to make sure degree is highlighted, and if not, you want to change it. So you don't want to be in radians right now. Leave that for when you get to trig. Okay? So if it's in degrees, you're good. If not, just make sure you go down and hit enter when you hit that, and then we can get out of mode. Second click. All right, so you're back to the home screen, and now we can start plugging these in. So when we're given an angle, this is considered a degree, an angle. So say I had a right triangle, any right triangle, and this angle was 35 degrees. That's what this represents. And when we plug this into your calculator, it will give us the ratio for any right triangle of the opposite to the hypotenuse ratio. So if we do that on here, you hit, oops, sorry, let me clear that. You go in here, and then these are the 3 buttons that you're looking for. So we just talked about sine, cosine, tangent. Hit sine, just put in 35, close your, oh, you can't see that, sorry. Sine, let me redo that. Sine, 35, close parentheses, enter. And that is the ratio. So it's a decimal, but it could also be a fraction, just like we did over here. For now, let's just record that. So 0.57, I'm going to round it. All right, so let's try cosine of 42 degrees. Cosine 42, enter. That's a little bit different. So when we change the angle and we change the ratio, the trig ratio, we get a different answer. So 0.74, and then tangent of 61. This is just to teach you how to plug them in here. And that's 1.80 approximately. Remember I said tangent is the only one that can be above 1, or an improper fraction. So 1.8. You can put the 0 if you want. Alright, so that's using your calculator. We'll talk more about that in a minute. So one thing that trig ratios help us to do, quite important, is if we have a right triangle, we only have one side length, and we want to know the other side length, and we know an angle. If we know that angle, and we know at least one side length, we can find the other side length. And once you have this side length, then you can use the Pythagorean theorem to get all the side lengths. So it's a pretty powerful tool to have just one side length and an angle and be able to get the perimeter. You can tell me what all the sides measure. So what we want to do here is look at, okay, we're looking at this angle, and we want to find this side, which if we look across, what side is this? Well, it's the opposite side. And we have this side, which is not the hypotenuse because that's the longest side, so it must be adjacent. Well, I have to think about what sides do I have and which ratio should I use then. So here I have just opposite and adjacent. The only one out of your SOHCAHTOA, sine, cosine, or tangent, that does opposite and adjacent is tangent. So that's the one you're going to want to pick in order to set up these problems correctly. So here's the magic of trigonometry. If I say tangent of a certain angle, you always do it of the angle. So we're doing tangent of 58. Any tangent is equal to opposite over adjacent. So in this triangle, that is x over adjacent is 11. This is my equation. Now you're moving on from algebra and starting trigonometry. But they are solved just like an algebra equation. So if I had up here, let's say we had x over 11 equals 8. How would you solve this? You would multiply both sides by 11, right? And you would get x. Same thing here. This functions as one big number when you put it in your calculator. So I'm going to multiply both sides by 11. And in my calculator, I will put 11 tangent 58, and it will multiply it for you, equals x. So let's see what x equals. We're going to plug it right on in. 11 tangent, what did I say, 58? Yes, 58, 17.6. And if we put that in as x, doesn't that look about right? It's a little bit longer than this side. So this side, now we had an angle, we can find what this side is. It's 17.6. Let's try that again with a different type of thing. So, oh look, we have an angle and we have one side length, but we're trying to find another. It's a mystery. We can use a trig ratio to find that side. So the way we're going to do that is look at what two sides we have, what labels can we put on them. So if I'm looking at this angle up here, this side across must be opposite, and this is the longest side of the triangle I see, so it must be hypotenuse. Which of the trig ratios has to do with opposite and hypotenuse? That is sine. So instead of using tangent, because up here we were working with different labels, we want to pick sine this time because we have opposite and hypotenuse. So I'm going to say sine of the angle, sine of 53, the angle, and sine is always opposite, 11 over a hypotenuse, x. Alright, so this one's a bit different than the one up here. This one was a little easier because we could just multiply by a number and then x was by itself. Gonna have to do a little bit of work on this one. So we would solve it kind of the same way, but we want to multiply both sides by x. So we're gonna wind up getting x sine 53, just moving it to the other side, equals 11. And then this functions, like I said, as just one number, so I'm going to divide by it, because this is like a multiplication. We just multiplied by that number. Alright, so what I'm going to wind up putting in my calculator after this cancels is x equals 11 divided by sine 53. Let's see what x equals and see if it makes sense. So if we are correct, the hypotenuse is the longest side of the triangle, so if I put this in my calculator, I better get something that's bigger than 11. Let's see. But not something outrageous like 200. It needs to be a triangle after all. So, 11 divided by, now be careful with your parentheses, you have to hit sine, and you have to close parentheses at the end, 53. Yeah? And that is 13.8 approximately, which looks like it would just about fit in this triangle. Awesome. All right, so it says try this on your own, but we're going to try it together via video. So you want to build a skateboard ramp with a length of 14 feet and an angle of elevation of 26 degrees. An angle of elevation is simply, if we were looking at the ground, it's how far we would have to look up. So you would be looking this way. And the angle of elevation is simply from the ground to how far you're looking up. All right, so we want a length of 14 feet and an elevation of 26 degrees. And I want my ramp to be 14 feet long. The question asks, find the height. So in other words, we want to find the height over here and the length of the base, or this part. Ignore this. This is extra ground I made. So we got length of the base, height. Okay, let's do it. So when we look at this angle, let's start with H. That would be opposite of this angle. This is the opposite side. 14 we know because it's a right triangle, it's the longest side, it must be the hypotenuse. Which of your trig ratios we just learned have to do with opposite and hypotenuse? Well, if you say so, Katoa, only sine or so has to do with O and H, or opposite and hypotenuse. So I'm going to set that up to begin with. So sine, remember we're doing sine and you put in the angle, 26 equals opposite, which in this case we don't know is h, over hypotenuse, which in this case is 14. We're just going to multiply both sides by 14, and we wind up getting 14 sine 26 equals h. Put that in my calculator really quickly. What did I have? Oh, 26. And that comes out to 6.1. So if we looked at the height of a skateboard ramp, that's about right. Looks about right. So h equals 6.1 feet. Okay, now let's do the length of the base. So we want to be able to find this. Now you could theoretically use the Pythagorean theorem and you would be able to solve for this length. But a lot of times it's easier because trig ratios are just 2 steps and then you plug it straight in your calculator. So it's a lot less work than the Pythagorean theorem. So when we look at L and we have this angle, L is not opposite and it's not hypotenuse, so it must be the adjacent side. If it's the adjacent side, we want to find it and we know the hypotenuse for sure, I would not use the one you just found in case you get that wrong, because if you use that one, you'll also get this one wrong. So I always say use the one that's already been given to you, the side length that's been given to you, because if you make a mistake on one, you won't make it for both necessarily. Alright, so we have adjacent and hypotenuse. We know, oh, that's from cosine. So I'm going to set that up because we want to find the adjacent. Cosine 26 equals adjacent, or L, that we don't know, over hypotenuse, which we do know is 14. Same process, we're going to multiply both sides by 14. 14 cosine 26, because that trig ratio acts as just one number, equals L. Let's figure out what that is. 14 cosine 26. That is 12.6. L equals 12.6 feet. And that probably should make sense in your head because it needs to be smaller than the hypotenuse, but a skateboard ramp is probably longer than it is high. Otherwise you'd be, you know, going up a skateboard vertically like that. That would not be so good. I know you love my drawing. And that takes us to the end of these first trig notes. I know that was a lot to throw at you at once, but what I want you to remember is that trig ratios help us find missing side lengths or missing angles. We'll get to that in the next notes. But for now, in this notes, we saw that if we have an angle and one side, we can find the missing side lengths. And that's what trig ratios do, as long as you know how the trig ratios relate to the angle. In other words, what label, adjacent, opposite, or hypotenuse that you put on them. All right.